Hello info person, this is Anton, and today we're going to discuss some new updates in regards to the third interstellar comet detected in the solar system, the comet referred to as 3I Atlas. And we're actually going to talk about something somewhat important, mostly because, once again, this comet has received a lot of buzz online. That's also, unfortunately, is getting a little bit too speculative and a little bit too bizarre. And so because of these new headlines, and also because of the recent email I received, I wanted to discuss the subject once again, focusing primarily on scientific facts and everything we know about the subject. And so before we start the video, I wanted to briefly address a very important concern that has now been voiced by a lot of scientists out there. As a matter of fact, this is based on several emails I've received in the last few weeks. And here we're talking about emails from actual scientists that are unfortunately somewhat upset. And so here researchers behind this recent study, especially Rohan Rahat-Gaonkar and the international team you see on this list, expressed deep concern that their work is being misinterpreted and actually miscommunicated by invoking very unusual exotic explanations involving aliens, and specifically alien probes. And I guess here you're probably aware who's doing all of this and why this is creating so much controversy. The Israeli researcher working at Harvard, who has unfortunately been completely misinterpreting all of these results just to once again fit his own agenda, and so that he basically can sell more books. And as I promised in some of the previous videos, we're just not going to discuss his work anymore, just because it's become completely ridiculous. And really because of what's being mentioned by these scientists and what most of the scientific community is now definitively stating. None of them support or agree with any of these interpretations, especially interpretations that attribute all of these observations to some kind of an alien spacecraft or advanced technology. Because in this study and several other studies, the evidence suggests unusual chemical signatures that can be easily explained through natural astrophysical phenomena, and actually present us with some really exciting explanations about different star systems, which is really the primary purpose for most of these studies. It's not for Avi Loeb to sell books or to try to find aliens, it's to actually figure out where this comet is from and what other star systems are like. And so understanding the chemical makeup of this object is already profoundly exciting and does not need to be embellished with some kind of an unsubstantiated claim. Because honestly here, just the science itself is already super exciting. I mean, for astrophysicists. And that's because this object is only the third such object we've ever confirmed, and it's already providing us with a very important discovery into both chemistry and physics of distant stellar systems. And so let's discuss exactly what these new discoveries are, and of course start with a very brief summary of what we know already. So, first discovered on July 1st, 2025, this object stood out because it was moving ridiculously fast, over 58 km per second. And so with a very hyperbolic orbit with eccentricity of 6.14, this was the first such object ever seen. This trajectory screamed interstellar visitor. And in the last few weeks, it's actually really because of these very powerful new telescopes that it's become possible to not just track this object, but to accurately analyze its structure, its size, and even its composition, and even discover it in some of the archival data, including telescopes like TESS that apparently have even seen it back in May of 2025. Roughly 2 months before the official discovery, with this test data suggesting that the comet was already active, even at a distance of 6 astronomical units. And this is one of the more important discoveries because we don't expect comets to be active yet, especially when they're beyond the orbit of Jupiter. And so this very early outgassing, which in most comets happens much closer, suggested that this was a pristine object containing a lot of very specific ices that started to evaporate very quickly. And it actually increased in brightness quite fast, which essentially suggested that it was outgassing or releasing all of this gas much faster than most comets in the solar system. And researchers discovered that this was the result of hypervolatile materials such as carbon dioxide and carbon monoxide, which normally have a much lower sublimation point compared to what we usually find on comets, which is water ice. With this being a very important first hint, it suggested that comets from other star systems might of course have different composition to the ones we typically find in the solar system. With these suspicions officially confirmed when the James Webb Space Telescope observed this back in August of 2025. And so here on August 6, using the near-infrared spectroscopy, and at a distance of about 3.3 astronomical units away from the Sun, James Webb was able to capture the comet in a lot of detail, and most importantly observe its spectroscopy as well, with these first results being absolutely groundbreaking. First of all, it revealed that the comet here, or the fuzzy atmosphere surrounding the nucleus, was primarily made out of carbon dioxide. As a matter of fact, there was approximately 8 times more carbon dioxide compared to water. This was the highest CO2 to water ratio ever seen in any comet out there. Okay, technically there's another anomaly you see right there. The comet known as 2016 R2 with a period of about 20,000 years, but here it was eventually established that this particular comet seems to belong to a rare family of comets existing on the outskirts of the solar system, or could also be some kind of a fragment from a much larger Kuiper Belt object, such as a dwarf planet. And so it will be very exciting to see some kind of a study comparing these two comets, because they're both very anomalous. But still, we know that these are comets, because James Webb also observed carbon monoxide, water, carbonyl sulfide, and specifically in amounts that we do expect from a typical comet. And so although there are some anomalies, for the most part, it looks like a duck, it quacks like a duck. So it's a comet. But what exactly does this tell us about this object? Well, because there is so much carbon dioxide, it may mean that the ices in this comet were exposed to much higher levels of UV radiation around its host star system. Or basically it came from a star that was maybe hotter and more massive, which dramatically changed its surface composition compared to what we have in the solar system. Another possibility is that it formed beyond the carbon dioxide line, so basically really far away from the star, and has never really seen any other stars, and was then somehow kicked out of the system without interacting with the star at all. As a matter of fact, it potentially did not interact with any stars, with the Sun being the first. But in order for it to get kicked out from such a faraway distance, it would either have to be some kind of a massive planet on the outskirts, or possibly this came from a binary system, where the two-star interaction might have affected its orbit. But on top of this, when it comes to the carbon isotope ratio, specifically measuring carbon-12 to carbon-13, which was also by the way visible here, it was discovered to be very similar to Earth, suggesting that its material was created in a very similar environment to the solar system, with very similar carbon species composition, and possibly even around a star system that's not too different from our own. But we also obviously have a lot of other observations with other telescopes, with additional observations from, for example, VLT, or the Very Large Telescope, also detecting something else. Here the researchers detected the onset of atomic nickel emission lines, and later on cyanogen gas emissions. And this is of course what this new study was about, and it was these nickel emissions that unfortunately caused Ivy Loeb to once again start talking about aliens, which is why the researchers behind the study decided to reach out to me and highlight the fact that he seems to not understand what the study is about. And so let's discuss these nickel emissions and what it actually means based on the study. So here scientists did detect numerous nickel lines, but the iron emissions remained undetected. And here nickel is not unusual at all. It's been detected in atmospheres of a lot of different comets, or to be more exact, in approximately 20 different comets, as well as the previously discovered interstellar comet, Comet Borisov. As a matter of fact, there is one study you can find in the description that specifically talks about nickel and iron detected in a lot of different comets, with many heavy metals evaporating from these comets, but whose origin is still not entirely clear. As in, scientists are not certain why some comets have nickel, other ones don't, and how nickel can even get that far in a solar system. And so the detection here is particularly significant, especially because metals like nickel and iron require extremely high temperatures, usually over 700 Kelvin, in order to sublimate. But finding nickel in these colder distances around 3 astronomical units suggests that it's been efficiently released from low activation energy carriers, most likely via some kind of a photochemical process or photochemical reaction, or basically stuff on the surface of the comet reacting with the sunlight. And in this study, researchers do propose one potential candidate, nickel carbonyls. Incredibly volatile elements that obviously do contain nickel and can photodissociate pretty easily. And so in other words, they do provide a very reasonable scientific explanation using an actual element that we know exists in nature. But the mystery here is not nickel, it's why there seems to be no iron. The absence of detectable iron, which has been discovered in the solar system comets, means that iron carbonyls are possibly either less stable or don't form in these water-rich conditions as easily. Or basically, they either don't exist, have not formed on this comet, or maybe for some reason in this comet they just seem to be absent. And this is a really crucial finding because it challenges traditional understanding of how metals are released from comets, and also offers new insights into chemistry of distant star systems and their protoplanetary disks. Because here, for all we know, maybe for some reason, this star system is not enriched in iron, which actually would be super bizarre. And so here the production of nickel increased very steeply as the comet approached the sun, hinting that it was the heat that was suddenly releasing more and more stuff, but also obviously creating this new mystery that's somewhat challenging to solve right now. But in this case, this chemical mystery is not going to be solved anytime soon until we get even more analysis or until we can actually compare this to some of the comets in the solar system. And especially comparing this to the comet you see right there, C2016-R2. And in some of the previous videos, we also discussed that it's quite likely this comet potentially came from the thick disk of the Milky Way. Based on its trajectory and based on the velocity, it possibly came from the region containing much older, low metallicity stars, anywhere from 7.5 to maybe even 9 billion years old, or possibly even older. And so here maybe its compositional mystery is somehow related to the ancient star it came from, as in maybe it just has a different composition because the star was much older and did not contain these same chemical elements. But because this comet is still approaching the sun, and also because it's actually going to disappear behind the sun for at least a couple of months, the research about this object is obviously still not finished. As a matter of fact, in the next few months, we're going to have additional observations, even from observatories and spacecrafts that are not even designed to observe comets. For example, NASA's SOHO, or the Solar Observatory, and the now famous NASA's Parker Solar Probe. And that's because these observatories are going to be able to see the comet behind the sun. And so as the comet passes through the fields of view of several solar observatories, it's quite likely that we're going to receive additional data, offering more opportunities to study its composition and its real-time behavior. But I guess before we finish, so what's the big takeaway right now, as of September of 2025? Well, first of all, we know that this is a very unique object. Pristine primordial remnant from another star system, possibly much older than the Sun, that seems to contain very specific signatures of primordial interstellar chemistry. And since it has this very bizarre composition, with the highly enriched carbon dioxide coma, and emissions of nickel but no iron, it also now suggests that the cometary material across the galaxy is not necessarily universal and is not necessarily the same. It seems to vary from star to star, and obviously we still have no idea exactly where this came from, or what kind of a star system it was born around. By studying this in more detail, we'll hopefully understand how these objects form, how they get ejected, and more importantly, understand how these objects exchange materials with other star systems, or possibly even seed planets like Earth. I mean, some of the stuff that's being evaporated right now, at some point might end up on Earth after all. And so understanding and studying this is obviously quite important. But honestly, I'm really waiting for observations from the now functional Vera Rubin Observatory, because chances are it's going to be detecting these objects left and right, possibly even finding one per month. You can learn about why in one of the videos in the description. And so hopefully here, by studying these objects, we can learn a little bit more about the effects from these comets on other star systems, and also maybe learn about the fascinating concept of panspermia, which has been suggested before. So can these comets potentially transfer life from one star to another? But until future discoveries, future updates, or I guess until future concerning emails involving Avilobe, that's all I wanted to mention. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access and a few more secret videos. Additionally, you can buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.